Hello students, welcome to e-Gyan YouTube channel. Myself Shivanand Unale, lecturer in mathematics. Today we'll discuss about applications of derivatives. So in this topic, there are total 5 concepts are there. First one is derivative as rate measure. Second one is increasing and decreasing functions. Third concept is tangent and normal. Fourth one is approximations, and fifth one is maxima and minima. So let us start with this first concept, derivative as rate measure. So derivative as rate measure, so the ratio delta y by delta x is average rate of change of y with respect to x, where delta x represents change in quantity x and delta y represents change in quantity y. So this ratio delta y by delta x is the average rate of change of y with respect to x. Now if we apply the limit delta x tends to 0 to delta y by delta x, so that is delta x tends to 0 delta y by delta x, here x becomes very small, then this limit is denoted by dy by dx, that is limit delta x tends to 0 delta y by delta x equal to dy by dx at x equal to x naught. Now here limit delta x tends to 0 delta y by delta x equal to dy by dx at x equal to x naught. So this represents rate of change of y with respect to x at x equal to x naught. So dy by dx at x equal to x naught, this term represents rate of change of y with respect to x at x equal to x naught. Now rate of change of quantities, rate of change of quantities. So here the rate of change of displacement. So rate of change of quantity means, so rate of change of one quantity with respect to other quantity. So for this one, rate of change of displacement, that is s, with respect to time t is called velocity. So this one we can represent, that is ds by dt. So this term is nothing but velocity. So ds by dt, this represents change in this quantity s with respect to time t. So that one we can represent in terms of ds by dt. Now change in this displacement with respect to time is nothing but velocity. Next, similarly here, rate of change of velocity v with respect to time t is called acceleration. So this one we can write in terms of dv by dt. So change in this velocity with respect to time t. So this term is nothing but acceleration. The next, rate of change of area a with respect to time t is given by dA by dt. The next one, rate of change of volume V with respect to time t is given by dV by dt. Next, the rate of change of surface area S with respect to time t is given by ds by dt. Now here some important formulas are there. So those formulas you have to remember. So the first one is area A of a circle with radius r is, that is A equal to by r square. So this one is a area of circle formula. The second one, circumference C of a circle with radius r is C equal to 2 times pi r. So this one is a formula for circumference of the circle. Third formula is area A of a rectangle with length L and breadth B is given by A equal to L into B, that is length into breadth. The formula for area of rectangle. Next, number 4, perimeter P of a rectangle with length L and breadth B is given by P equal to 2 times L plus 2 times B, or this one we can remember as 2 into L plus B. Number 5, area A of a square with side A is A equal to A square, that is area of square. Number 6, perimeter P of a square with side A is given by P equal to 4 times A. Number 7, volume V of a cube with side A is given by V equal to A cube. Number 8, surface area S of a cube with side A is S equal to 6 times A square. So this formula for surface area of cube. Number 9, volume V of a sphere with radius r is, the volume of sphere formula is V equal to 4 by 3 into pi r cube. Number 10, surface area S of a sphere with radius r is given by S equal to 4 times pi r square. Surface area of sphere formula is S equal to 4 times pi r square. Next, number 11, volume V of a cylinder with base, radius r and height h is given by V equal to pi r square h, volume of cylinder. Next, number 12, surface area S of a cylinder with base, radius r and height h is given by S equal to 2 times pi r h plus 2 times pi r square, or S equal to 2 pi r into h plus r. So this one is a formula for surface area of a cylinder. Next, number 13, volume V of a cone with base, radius r and perpendicular height h is given by V equal to 1 by 3 pi r square h. So these are the total 13 formulas are there. So these formulas you have to remember. So by using this one, now next we will discuss some examples. Examples. First example, find the rate of change of the area of a circle with respect to its radius r when A equal to 3 centimeter and B R equal to 4 centimeter. So in this example, you have to find out the rate of change of area, means area of circle with respect to radius r. So this one you can solve. First you can start with, let A denote the area of the circle of variable radius r. So area of circle formula is A equal to pi r square. Next, rate of change of area with respect to r. Rate of change of area A with respect to r. So this term is nothing but you have to differentiate with respect to r. So once if we differentiate this term with respect to r, so we get dA by dr equal to 2 times pi r. Call this equation number 1. Next, by using this equation number 1, now we can calculate rate of change of the area with respect to r when r equal to 3 centimeter. So it's the first A. When r equal to 3 centimeter, then so this dA by dr equal to this 2 times pi constant term as it is. Next put r equal to 3 in equation number 1. So we get dA by dr is equal to 6 times pi square centimeter per centimeter. Means here for 1 centimeter of radius, if 1 centimeter of radius, if change in that radius, if 1 centimeter change in that radius, then so the corresponding change in that area will get 6 times pi. Second one, in this one, sub example number 2, when r equal to 4 centimeter, then dA by dr is equal to 2 times pi into, from equation number 1, you will get 2 times pi into 4. So we get dA by dr equal to 8 times pi square centimeter per centimeter. So change in this area is, we get 8 pi square centimeter when change in that radius is 1 centimeter. Next, example number 2. The volume of a cube is increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing when the length of an edge is 12 centimeter? So in this example, so what is the given term here? The volume of a cube increasing at the rate of 8 centimeter cube per second. So what is the formula for volume of cube, or what it represents? So here in this example, first you can start with, let x centimeter be the edge of the cube. Next, what is the given term here? So the given term is rate of increase of volume of cube, that is increase of volume with respect to, here time is given, so here we will get dV by dt is given, that is 8 centimeter cube per second. So this one is a given term, that is volume of cube increasing at the rate of 8 cm cube per second. Now by using this given term, now you have to find out how fast is the surface area is increasing. So when volume changes, then the corresponding the surface area also changes. Now when if increasing the volume of cube at the rate of 8 cm cube, then how fast is the surface area is increasing? So that one you have to find out when the edge is 12 centimeter. So we can take first the volume of cube formula. So the volume of cube formula is V equal to x cube. Next we can differentiate this term with respect to t, means the change in the volume with respect to time t. So we get dv by dt is equal to 3x square, 3x square. So we are differentiating with respect to t and the given variable is x is there. So we have to take with respect to term here, that is dx by dt. Now this implies here dv by dt is already given, that is 8 equal to that right hand side term as it is, that is 3x square into dx by dt. Now therefore dx by dt is equal to 8 by 3x square. So call this equation number 1. Next, let S be the surface area of the cube. Let S be the surface area of the cube. That is, the formula for surface area of the cube is S equal to 6 times x square. Now rate of change of surface area of the cube, that is ds by dt. So you have to differentiate the given term with respect to t. So we get ds by dt is equal to 6 into derivative of x square is 2 times x, and here we are differentiating with respect to t. So we'll get with respect to term is dx by dt. So derivative of 6x square is 6 into 2x into dx by dt. Now this implies 12 into x into, so here dx by dt is 8 by 3 x square is there. You can put dx by dt is equal to 8 by 3x square by using that equation number 1. Now simplify this one. So we get 4 into 8 by x. So in this one you can cancel. So denominator is 3 is there, and here 12 is there. 3 ones are and 3 fours are, and x into here denominator x square is there. You have to cancel one x term. We get 4 into 8 by x. Now simplify this one. We get 32 by x. Now here x equal to 12 centimeter is given, means change in the surface area when that edge is 12 centimeter, means put x equal to 12. We get 8 by 3 centimeter square per second. So ds by dt means change in this surface area with respect to time t, that is 8 by 3 centimeter square per second. Next, example number 3. The radius of a circle is increasing uniformly at the rate of 3 centimeter per second. So first given term is the radius of a circle is increasing uniformly at the rate of 3 centimeter per second. Next, find the rate at which the area of the circle is increasing when the radius is 10 centimeter. So next, by using that first given term, you have to find out the rate at which the area of the circle is increasing when the radius is 10 centimeter. So in this example, so change in that area of circle when that radius is 10 centimeter. So this one you have to find out. So first you write down this given terms. So first you can take this. You can start with, let R be a radius and A be the area of the circle. And what is the given term here? The radius of the circle is increasing uniformly at the rate of 3 centimeter per second. This is a given term. Next, So what is the meaning for this one? So increasing uniformly at the rate of 3 centimeter means, for example, when t equal to 1 second, then radius will be 3 centimeter. When t equal to 2 second, means for second you will get the change in that radius is total 6 centimeter. Similarly, when t equal to 3 second, you will get r equal to 9 centimeter. So this one is a uniform change in that radius of the circle. Now, by using this one, you have to find out dA by dt, change in this area of the circle with respect to time t when r equal to 10 centimeter. So first you can start with the formula, that is area of the circle is a equal to pi r square. Next, by using that formula, first you have to differentiate that term with respect to t, that is rate change of area of circle A with respect to time t is given by dA by dt is equal to, the right hand side term is, the pi is a constant term as it is, or you can take this derivative of pi r square first and then you can simplify that one. So pi constant term as it is, so derivative of this r square is 2 times r, so with respect to term is dr by dt, or this implies that 2 times pi. So here r is given, that is 10 centimeter, that is 10 into dr by dt also given, that is 3. So if you simplify this one, you will get 60 times pi. So here dA by dt is 60 times pi square centimeter per second. So I mean change in this area, so with respect to time. Next, example number 4. An edge of a variable cube is increasing at the rate of 3 centimeter per second. How fast is the volume of cube increasing when the edge is 10 centimeter long? So in this one, the given term is an edge of a variable cube is increasing at the rate of 3 centimeter per second. So by using that given term, you have to find out how fast is the volume of cube is increasing. Okay. So first you can start with, let A be an edge and V be the volume of the cube. So what is the given term now here? dA by dt. So changing that edge. So here edge is A. So it is changing that edge with respect to time t, that is given, that is 3 centimeter per second. Next, by using this one to find dV by dt. Now I have to find out dV by dt when A is equal to 10 centimeter. So first I can start with that formula. The volume of a cube formula is V equal to A cube. Now first write down that volume of a cube formula is V equal to A cube. Then you have to differentiate this term with respect to t, that is rate of change of this volume of cube V with respect to time t is given by dV by dt is equal to, so we get, so the derivative of this A cube with respect to time t, so we get 3 times A square. Now we are differentiating with respect to t, so with respect to term is into dA by dt. Now if we simplify this one, 3 into, so here A is given, that is 10 So here a square is there, so 10 square into, so dA by dt also given, that is 3 centimeter. So we can substitute here dA by dt is 3. Now simplify this one, so we get 3 into 100 into 3. Now this implies 900 centimeter cube per second. That is change in this value with respect to time t when that edge is 10 centimeter. So I hope you enjoyed this session. So thank you very much for watching this video. Thank you.